So as mentioned in the email this video is attached to, a Ferris wheel has a radius of 11 meters and rotates once every 30 seconds. What is the apparent weight of a 70 kilogram person while at the top of the ride? What is the apparent weight of the same person at the bottom of the ride? Well, the first thing I did was draw a little diagram to illustrate what was going on and to show that the acceleration is always going to be aimed at the center with circular motion. And the radius and w squared is also included. Now w is going to be equal to 2 pi radians divided by the 30 seconds that was given, and that will give me 0.209 radians per second. And to answer the first problem that this question has given, I drew a force by diagram to show the forces acting on the person at the top of the Ferris wheel, with the normal force pointing up, but it is not as great as the force of the mass and gravitational pull. So to find this force, I use the equation of the sum of the forces in the y direction is equal to the mass times acceleration. And then I used n minus mg is equal to negative mw squared times the radius. And then from there I use the formula n is equal to mg minus mw squared times the radius. And after plugging my values in for that, I get that the force at the top is going to be 652 newtons. And then the second part of this question again was what is the apparent weight of the rider while at the bottom. And again, I drew a force by diagram to illustrate the forces acting on him. Now, this time, the normal force is greater than the mass and gravitational force that's pushing down. So I use the formula here, which is the sum of the forces in the y direction, is equal to n minus mg, which is equal to mw squared times the radius. And then I was able to use n is equal to mg plus mw squared times the radius. And after plugging my values in for that, I get that the apparent weight of the person at the bottom of the ride is 719 newtons, which is greater than his weight at the top of the ride, which we can accept as true